Figure shows a square current carrying loop ABCD of side 10 centimeter. Here it is a square current carrying loop placed in such an orientation, as you can see, that one side is parallel to the y-axis and this edge is making an angle 30 degree with the x-axis. So the plane of this square is like that. Okay. So magnetic moment M of the loop is this particular square of side 10 centimeter carries current 10 ampere. Magnetic moment M of the loop is. So first of all, what is the magnetic moment of a loop? So magnetic moment of a loop can be represented by mu, and it is equal to current into area. Basically, the magnitude of the magnetic moment is current into area, and in case there are more than one number of turns, then we can always multiply it with the number of turns, and Ia will become the mu. But magnetic moment is a vector quantity and its direction is perpendicular to the plane. Direction is perpendicular to the plane of loop. Okay, according to the right hand rule, if we curl our fingers in the sense of current, then thumb points in the direction of mu vector. So here, if we look at this diagram from the top, then what we get to see is this. Here it will be our x-axis, it is our z-axis, and y-axis is pointing outward. So according to this right hand rule, direction of magnetic moment vector will be perpendicular to this plane this way. Okay, so mu will be directed this way and it is perpendicular to this plane. Since plane is making an angle 30 degree with the x-axis, that means here with the negative z axis, this mu vector is making an angle of 30 degree. That you can understand yourself easily. So first of all, let us calculate the magnitude of mu here. So magnitude will be, say, number of turns is 1, current is 10 ampere. So it will be 10 multiplied with the area. Since side is 10, so 10 by 10, 100 centimeter is square. Or we can say 0.1 meter into 0.1 meter. So how much it becomes? It becomes 0.1 ampere meter square. This much is the magnitude of mu vector. And since mu is in this direction at an angle 30 degree with the negative z-axis, then we can find its components along these two directions, along the x and along the negative z-axis. So this particular component will be mu sine 30 and this particular component is going to be mu cos 30. So mu cos 30, that means 0.1 into cos 30 is how much? Under root 3 divided by 2. And mu sine 30, that means 0.1 multiplied with half. So mu vector can be written as how much? 0.05. It is along x-axis, that means I cap, and this much along negative z-axis, and it is 0.05 under root 3 k cap. So here you can see that option A will be the correct choice for this particular question.